Hey everybody, so I've gotten a lot of questions about these particular homework problems for tonight. This is 23 through 25, so I just wanted to make a quick video and go through how I would go about solving some of these problems. So what I'm going to do is I'm going to solve 23, so I'm going to actually solve number 23 here, and then I'm also going to go ahead and solve part of 25. So those are the two pieces that I'm actually going to do. So it's very important in these problems that we fully read the bolded instructions first. So an airplane at a constant altitude A flies a horizontal distance d towards you at velocity v. You observe for time t and measure its angles of elevation E1 and E2 at the start and end of your observation. Find the missing information. So that is a lot of words. So what you want to do is you want to deconstruct it and you want to build a picture, right, for 23 and for number 25 slowly. So deconstruct what it's asking for and then construct the actual image of what your problem is going to be. All right, so for number 23. Well, it looks like the thing that we're looking for, the thing that's blank, is going to be my A. So I know that I'm going to be looking for A, and I know that A is altitude. And the altitude is the altitude of the plane. So now I know I'm working with a plane. The plane is at some altitude, right? And it's flying horizontally, and I'm on the ground, right? I'm observing it from the ground because I know that I have an angle of elevation. So let's go ahead and construct what this will look like. So I'll just go ahead and draw the ground, and I'll put a little red dot on the ground. That's where I am. And I'm watching this airplane, and this airplane is going to be in two different places. So first I'll just draw my vectors. So my first angle of elevation is 45 degrees. So I'll just go ahead and draw a line at a 45-degree angle from where I'm standing. So that's where the plane is going to be. So that's a 45-degree angle right here. So that's 45 degrees. Then my second angle of elevation is going to be 90 degrees. So my second angle of elevation will be 90 degrees, which, as we know, is going to be looking straight up. So that's actually a right angle that I've formed now with my second observation of the plane. All right, great. And the thing that I'm interested in is what is this altitude that the plane is at. So this is my A over here. So this is the piece of information that I'm actually interested in. We notice that this height right here is also going to be A. Now, the next piece of information that I have is the fact that my velocity is 5 miles per minute. And I know that the time between my observations is 1 minute. So if I want to get displacement, or I want to get a distance, then I'm going to say distance is equal to velocity, which is 5, times time, which is 1. So my distance will be 5. So this distance up here that my plane actually moved is going to be 5. Okay, well, now let's make some observations. So if my angle of elevation to the plane was 45 degrees, then for this first point here, the angle of depression of the plane looking at me will be equal because of our alternate interior angles theorem. So now that's a 45-degree angle. But if that's a 45-degree angle, and this forms a right angle here, then I have a 45, 45, 90 triangle, and therefore I can solve for A. A will equal 5. So we had to do a lot of diagramming to get to this point. So that's my suggestion to you, is make sure that you diagram the problem first and then start looking for the things that you need to find. So I'm going to go ahead and go to the next page and do part of number 25, and then I will be done. All right, again, so for number 5, I'm given my first angle of elevation. My first angle of elevation is 50 degrees. So I'm going to go ahead and draw an angle of elevation at 50 degrees. Okay, so I'll just go ahead and mark this as 50 degrees. So that's my first observation of the plane. All right, then my second observation of the plane, well, I don't actually have that. So I'm not sure what my second angle of elevation will be. Now, I am going to assume that the plane is going to move towards me, so I'll go ahead and make another line, and I'll have the plane be here, and we'll go ahead and just make that a purple dot here. And so that'll be my purple angle, and that's an unknown, so we'll just call that x for now. All right, let's talk about other things that we do know. So some other things that we do know is the altitude that the plane has. And the altitude is given to us as 4 miles. And all of our units are miles in this problem, so I'm not going to mark them right now. So the other thing that I have is the displacement here between the first and second points. So this is actually going to be 3. And now what we're going to try and do is find my angle of elevation, right, that x naught, and then we'll also need to find, in our problem, t is blanked out. So I also need to find the amount of time that passes between my first observation, which is green, and my second observation, which is purple. All right, so let's first talk about t, because that'll be pretty easy. So my displacement here was 3 miles. So I know my velocity, and I know that velocity times time is equal to displacement. So if my displacement was 3, and I know the velocity is 6, I can solve for t by dividing both sides by 6. And so t is equal to 1/2, or 1/2 of a minute, or 30 seconds. All right, so I found that t is 1/2. And now I want to solve for x naught. All right, so I'm going to go ahead and pull out this triangle here. So I'm just going to make a little sketch of our triangle. All right, and let's talk about the things that we do know. So we're trying to find the triangle's height here. We're trying to find this degree measure, and first what we want to do is we want to go ahead and mark our altitude as 4. So that's something that we do know already, because the altitude never changes in this problem. So beyond that, we really don't know anything more about this triangle here just yet. So let's change gears a little bit, and I want to see if I can find any more measurements from what I already know. And the way that I'm going to do that is I'm going to look around and I'm going to say to myself, well, is there anything that will help me find x? Well, what would really be helpful is if I knew this segment here. And we'll go ahead and call that y. Because why do we care? Well, we'll find out here in a second. So we'll call that segment y. And I need to find some way to get y. Well, what about over here in this larger triangle, right? This larger triangle, this segment would be y plus 3. So I have a way for finding that segment. And I know that that segment is equal to y plus 3 because I've moved 3 miles since I took that measurement. So let's go ahead and set up our trig ratio and see if we can solve for this segment in the larger triangle with the 50-degree angle. All right, so I'm going to go ahead and call y plus 3 w. So if I'm trying to find w, I've got my opposite side here, my adjacent side here, and so I can set up tan 50 degrees is equal to 4 over w. All right, so let's go ahead and solve this. So we do our tricks or whatever we need to do, and we see that w is equal to 4 divided by the tangent of 50. And we see that W is equal to a number that's about 3.35639.8. And I'm going to just leave it at that personally because that's going to be precise enough for me. All right, so then I take W, right, and I'm trying to actually solve for Y. So Y is going to be, Y plus 3 is equal to W, so we need to subtract 3 from this. So W is equal to, Y will be equal to 0.35639.8, approximately. And I know that I'm rounding before I'm supposed to, but I'm just doing this for demonstration purposes. All right, so now I know Y, and now that I know Y, I can solve for X. So again, I'm going to use a tangent. So tangent of X is equal to opposite over adjacent, so 4 over Y. And Y now I can load with this value of 0.35639.8. And then from there, I'll just take the inverse tangent of each side, and that'll give me my answer. And what we'll get is that X is equal to something close to 84.9 degrees, but I'll go ahead and round that to approximately 85 degrees. All right, so as you can see, these problems, right, that we are having to do are a little bit complicated. However, they do show a lot of really good applications here. And this is more realistic for what you're going to be using these trig functions for, is these types of real-world finicky situations where you're trying to determine some missing information. All right, if you have any questions, let me know tomorrow. I hope that this video was helpful for your homework tonight. Have a good evening. Goodbye.